This is a very important question from the chapter Trigonometric Identities, where we have to prove this particular identity. So in questions like this, if we start from the LHS and if we want to arrive at the RHS, it becomes a bit trickier. I mean, I'm not saying that it's not possible, but it will end up eating your time, and time is a very crucial factor in your board exams. So in questions like this, there is a very important trick which I would like to teach you with this example. And the trick goes like this, that you have to separate the LHS and the RHS separately. So in LHS, I will solve this expression and I will solve the right hand side expression. And after solving, we will see that we are arriving at a common value. And hence we can prove that LHS is equal to RHS. This is a very important trick, so please pay attention to this. Now on the LHS, we have m square minus n square. So I will write the expressions tan A plus sin A whole square minus tan A minus sin A whole square. Here, if you see this expression, this is in the form of A plus B whole square minus A minus B whole square. And this is a known identity, right, in algebra. And this gives us the value of 4AB. And here A is 4 tan A and B is sin A. So this is my LHS expression after evaluating it. Now coming to right hand side, which is RHS. Here I have root under m n. So m is tan A plus sin A, and then I have tan A minus sin A whole root. Correct. Now this is in the form of A plus B into A minus B, which is A square minus B square. So tan square A minus sin square A. Now when we are at this point, we will be expanding the tan theta, which is sin square A upon my RHS. Sorry. Sin square A by cos square A minus sin square A. So I'll write 4 as it is. Now when I solve this particular thing, I'll get sin square A minus sin square A times cos square A upon cos square A. This implies 4 times. Now if I take sin square common here, let's say, I'll get 1 minus cos square A inside. Again I'll get cos square A. Sin square A upon cos square A is tan square A, and 1 minus cos square A, as we know, is sin square A. When I remove the root, I'll get 4 times tan A sin A. If you observe this, since 1 is equal to 2 implies LHS is equal to RHS. So let me know in the comments if you have any doubts on this. So please be very confident of this method, that if you are unable to start from the left and end at the right, so you can take a break, evaluate LHS separately and RHS separately, and see if after evaluating the two values are matching. Follow for more such content. Thank you.